Hello and welcome everyone to another Controlli webinar. Today, me, Paweł Szarmański, Solution Product Manager, and my colleague Tomasz, Solution Product Manager, will present to you our RAC18 IP, Niagara-enabled room application controller with 18 inputs and outputs. Let's start with a short agenda. During today's webinar, we'll go through the use cases of our RAC18 IP, the key hardware features, key software features, time-saving tools that will help you commission the controller and program them and maintenance the controller. And at the end, we'll do the live demo to present to you the controller and how it can be programmed live using Niagara framework. So without further ado, I will give voice to Tomasz to go with the hardware key features.
Thank you, Paweł, and hello, everyone. So we will go through the room application controller, which also zone application or unitary application controller is equipped with 18 input and outputs and IP connectivity. So let's start with the first base application. It's a Funcal unit controller with the built-in universal application for Funcal unit control, up to 256 different type of Funcal units, which can be configured using the deep switches. The second most common use case of the RAC18 IP is the zone control. And the last, but not least, is the direct digital control. So the device which is fully programmable can be used PC controller. And let's go through all the key hardware features which makes the device so flexible. We've got 18 inputs and outputs on board. For the universal input, the temperature, voltage, current, resistance, and which can also work as a dry contact input. We've got 4 digital inputs, which can work as a typical dry contact input, but also have the options to work as a high-speed pulse counter. 3 analog outputs in a range of 10 voltage, but can also act as a digital output or pulse with modulation output, and 2 triac outputs dedicated for heating and cooling thermal actuators, and 5 digital relays outputs. Together, it makes 18 inputs and outputs on board. The second key feature is the built-in fail-safe Ethernet switch, which allows to make the daisy chain connection. So it's one IP port allows to make a daisy chain connection using the Modbus TCP and backend IP connectivity. And what exactly fail-safe mean? It means that in case of power supply failure, the network communication is still upheld. So the network communication even without power supply. The RAC18 IP, thanks to the RS-485 and IP communication port, can be easily expandable. So we have one RS-485 communication port with the dedicated smart plug connection, which allows you to connect our wall panels. But in case you want to use the standard wired connection, we provide screwless terminal to use the standard wired connection. The smart plug provides possibility to connect up to 5 iSMA Controlli wall panels because the communication is provided together with the power supply. We've got 1 physical devices on our demo set, which is also connected using the smart plug connectivity.
I think we can show that to everyone. Like when we disattach the wall mounting panel control point CP, it is simply connected through the RJ45 that shares with the controller. The controller shares with the control point panel both power and communication over RJ45. So this is not IP connectivity, this is not PoE, this is actually our smart plug technology that powers up and shares the BACnet MSTP and Modbus RTU. So if we disconnect this cable here, that is directly connected to the RAC18, the panel will switch off. But once the cable is connected, is being powered, and starts the communication directly with the controller. And it can go back on the wall.
The RS485 is not limited only to our wall panels, because it can be used to connect our FCU controller and to build a cost-effective zone management. So using the RS485 port, which provides the communication using the Modbus RTU, both BACnet master and slave, and BACnet MSTP, client and server, you can connect and expand the devices, connect up to 128 RS485 devices.
I think another great feature that we have, while having the RS485 port and the IP ports, we can easily expand the number of inputs and outputs with our range of I/O modules. We have 3 families, mini family, where the input range and output range starts from just 4 inputs and outputs, both in RS485 and IP version. And the same goes from the Max family, with a specific type of input or output, like the Max 24i with 24 digital inputs, and the Mix family, which can greatly expand the capabilities of RAC18 with up to 38 inputs and outputs. And altogether, it makes 22 different types of IP and RS485 I/O modules that can expand the capabilities of RAC18 controller and not only.
Our product can be used worldwide, including the RAC18 IP. The controller has a BTL certificate confirming the compliance with the BACnet, but we also have the quality confirmation of the controller. We've got the UL certificate for United States and Canada market, and also the proof from the European market, CE and UK CE.
How about the accessibility of the controller? When we want to connect to the controller itself, we have 2 options. The first option is to go for the IP connectivity. We can reach the controller using the static IP addressing and the DHCP using one or the second Ethernet ports that makes just one IP interface. Or we can use our new feature that is going to be available with a software update for RAC18 IP. It means that every existing RAC18 IP on the market, all the new RAC18s that will be manufactured and sold in the future, can utilize the USB-C port connectivity. And it can be used for programming using local static IP address, using one of our 2 tools. So this is the new feature, and those feature comes from the Nano-Edge engine that is a part of our software technology in the RAC18 IP and not only, also in our VAV14 IP, which also shares the USB-C in its hardware, which means you'll be able to program it over IP or the USB-C as well. So let's look at some key features of Nano-Edge engine itself that are shared throughout our controllers. First of all, it's fairly programmable and it's based on cycle-driven applications. That means you can create application using logic blocks and a wiresheet, and you can drive not only one but multiple applications in time cycles. Those can be different time cycles for different kind of applications, even on the same controller. That means RAC18 IP can work as a HVAC controller and can have an application that has a cycle like 10 seconds. And at the same time, the controller can work with lighting application with the time cycle going up to, I believe it's 100 milliseconds, right? So this controller is extremely fast. Another important feature is the native BACnet data exposure. The controller itself can be discovered using the BACnet network, even out of the box. There is no configuration to do that. The feature number 4, which is the modularity with libraries, means you can create the application based on the existing libraries. You can install more libraries to the controller, and in the future, you'll be able to build your own libraries using the C# programming language. The controller itself is license-free. There is no physical license you need to buy or install to the controller. The only limitation is the number of data points this controller can work with and share to the BMS system. And we share with you free of charge tools that we'll show to you today and tell you more about. And I think another important feature is that the whole system is being constantly updated and improved. We have our improvement development cycle, as well as new feature releases that we share to the market frequently, like the upcoming 1.7 version of the NanoH engine itself. So let's switch now to the tools and applications that you can run on the controller. Let's start with the tools. For the users, we have prepared IC-Tool, which is our own free of charge and portable tool that allows real-time programming and managing of multiple connected devices. But at the same time, we created a special Niagara framework extension for our controllers that will allow not only to integrate the devices in Niagara framework. For that, we will use Modbus or BACnet, but will also give you the capability of configuration of the controller with the IP address, backups, application creation using the Niagara wiresheet, and of course, the whole commissioning process and integration. So this is what we have for you. Let's see how it looks in reality, firstly on the screenshot itself. So this is the first tool that displays the application coming from the RAC18 IP. This is actually part of our VEV application. And this is how it looks in the IC tool. I think this shows resembling similarity between how the application is displayed in both tools. And it really gives you the freedom of choice whenever you'd like to go directly with Niagara for one tool experience, or you would like to use the IC tool and the features and additional capabilities it has on its own. So maybe Tomasz, can you tell us a bit more about the capabilities of the controller itself in the IC tool?
Yes, so the first advantage of the IC tool is that it's free of charge. So you need no money to use the IC tool, you just need a computer, Windows-based computer. And this tool allows you to fully program and manage the NanoH engine devices like RAC18 IP, VAV, and more devices in the field. And in the tools, we try to make the tools so intuitive and as easy as possible. We just finished the new functionality. IP Manager allows you to easily deploy and change the IP address on many devices on site, and to easier maintenance your NanoH engine devices on site. So let's take a look how the IP Manager looks. What is the tool, the view? It's the tool to manage the IP, discover the devices which are already installed, fully manage the IP settings. What does it mean? Change the IP address, change the subnet mask, change the gateway address, activate the DHCP or deactivate the DHCP, and change the DNS port. We also provide the possibility to change the internal Ethernet communication with the tools. So in case you want to have your own custom port, you also are able to change it using the IP Manager tool. So it's the multi-device addressing using the IP Manager.
So does it mean that if I have, let's say, 50 controllers out of the box, I connect all of them on the same network, even with the default IP address, I will be able to reach all of them and address them separately, even if the IP address is exactly the same on all of them?
Exactly. So by default, the device is equipped with the static IP. So it's our standard since the beginning of the company. And you don't have to change the IP one by one. You can make the connection installation just out of the box and change the IP on site after the installation of the controllers.
I think even locally, with a daisy chain those controllers, you can really just address all of them.
Even on our address, we've got two devices with the same IP address.
That's pretty cool.
So in case you have already commissioned the system, we provide a multi-device manager, which allows you to speed up commissioning and the maintenance process. So imagine the iSMA Controlli company released a new software update, which is usually done each half a year. So, and you want to upgrade the devices because you want to use the new functionality. So using the one multi-device manager tool, you can manage the software, manage the libraries, make the backup of your new application, restore all devices with new application, change the time, and change the user credential. So using those new features, your managing of your site with nano-changing devices the time will be reduced.
I think especially with the FCU application that we have prepared for the controller, you can really easily just restore it as a backup to those 50 controllers we have just addressed.
Exactly.
And basically ship it to the building owner. That's cool. Okay. I think those are great features and even great add-ons for anyone who would like to use our RAC18 directly in Niagara framework. As it is just a free of charge tool you can download and just speed up your work, right? But when we look at the Niagara capabilities, we will look at the AnyTooling. The tool is called AnyTooling. This is our module that will expand the capability of your workbench. So let's look at the features of the AnyTooling before we go to the live demo. First of all, it's license-free. You don't need to do anything related with licensing the module itself. You just need to download it from our IC Connect application. It is an extension for devices in both BACnet and Modbus protocols, which means when you download the module, you will just need to open the module palette and drop the nano-changing device extension to one of those networks in your Niagara workbench. And the next thing is you can use it for real-time programming, right? So you will be able to log into the controller and open its wiresheet in the applications container and drop the data points, drop all the components we have in the libraries, and use them to create the physical logic on this controller to control the FCU, the zones, or any DDC application for rooftops or air handlers. We prepared also the complete device management, so you have access to the software manager. You can install the latest updates, like the 1.7 we are mentioning. It's going to be available as an update process. You'll have access to the applications manager, to all networks for the integration. So you can use the local IO network just to create the local application on the controller. Or you can expand it with the control point panels, touch point panels, or our IO modules, or the FCUs, or any RS-485 devices or IP devices over BACnet and Modbus. When you create your whole application, you're able to go to the backup manager and back up your RAC18 IP directly to your Niagara station. That means your backups will always be safely stored within your station. And if you are using the Niagara Cloud and the Recover, the latest addition to our portfolio, you'll be able to back up your station directly to the cloud, which means you're also backing up your nano-changing devices. And last but not least, of course, we have the RTC. On those controllers, you can set all the time settings independently, or you can just share it with the Niagara station. So it will take the time from your Niagara station. And the last feature, it works with any Niagara version starting from 4.11. That means you can use it in your workbench, you don't necessarily need to use our OEM IC workbench. You can go with Tridium, EMEA, or Vicon, or any other workbenches you're actually using. And now about the versions. Available today is the 1.0 version. It supports RAC18 IP and the Nano Engine operating system in version 1.5. And very soon we are coming with the update I've been already mentioning twice to support the VAV14 IP controller, the 1.7 version of the OS system. And we include also some new additions like saving part of the applications to the Niagara palette itself, so you can use it for later, copying, pasting between controllers, and much more, and lots of improvements just to increase the user experience using our AnyToolink. And that's not it.
Exactly. We mentioned today about the future products, so that the AnyToolink, it's not only dedicated to RAC18 IP and the VAV controller. We are still working on the future Nano Engine devices. Those who follow up since last 2 years know that we focused on the constantly development, and we are really on the final way to finish the zone application controller, the device with the 24 inputs and outputs and the DI2 interface on board. We are also going to have the new unitary application controller with extended number of data points and up to 28 inputs and outputs. And we still have a backlog, the smart actuator, the actuator with the fully programmable actuator with the input and outputs on board. And just to remind you, we also provide the information hub for you. So we've got the e-learning platform. If you want to have get knowledge about the Nano Engine and about the devices, we provide the e-learning trainings. The IC Docs is our platform for the documentation. To download tools like IC Tool, Niagara, we've got the IC Connect, one common platform for all our tools. And to use the FCU application, which was mentioned today, to control the fan coil units using the RAC18 IP, you need to download it using our support webpage. Now, let's go to live demo presentation.
All right, so let me stop sharing the presentation now and let's move to my desktop. So first of all, what you need to do to actually work with our Niagara extension and AnyToolink, you need to get the IC Connect. In the IC Connect, you can easily search for the RAC18 IP using the search function. And that's actually one of my favorite products, as you can see here. When you click it, you can read about the functionalities of it, as well as you can see all the supporting software. So we have the IC tool in different versions, and we have also the AnyToolink for Niagara. So once you download the AnyToolink for Niagara in our IC tool, you can easily open it using the Open button. Once it's opened, it will direct you to the folder that contains the necessary jar files you need to drop to your Niagara instance. Just to remind you, version 4.11 and up is supported. I'm going to showcase the demo on a version number 4.14 in our IC workbench. So just to give you a brief overview, I'll stop sharing the screen now for a second. Just to give you a brief overview of what we have on our demo board right now. We have the RAC18 IP. As you can see, there is no Ethernet cable going out of this controller, and it is not powered up. Yet it is powered up. There's no 24-volt DC in or AC in, but we have the USB-C connected to the controller that powers up it and allows to create a direct connection with my laptop here. The second controller I have here is powered up with 24-volt DC power, and it's connected over the IP with my laptop. So we have two RAC18 controllers, different kind of connection with them. So why don't we move back to the workbench? So now, as I mentioned, I'm connected here to our IC workbench version 4.14. And what we are going to do is we're going to connect to those RAC18s directly in Niagara framework. So what you need to do is to add your backnet network and configure it properly, so you can see your controllers here on the network. What we are going to do next is to add the devices, and once the devices are added, you need to open the connection. So the first controller that we will be logging to is the one connected over the USB-C port. The main view that we will see once the connection is established. To do that, you need to click right on the extension, click Actions, and just simply click Connect. This is the static IP address you would be using for the USB-C connectivity. I have here filled in properly because we are limited on time. We have only 5 minutes to do this demo. So this is already done. We can see all the statuses of this controller. This controller is running the OS version 1.7, and it's been running now for an hour. As you can see, there's no license. I mentioned there's a number of available data points. So when we extend the tree of this extension here, we can see 3 things. Software manager, we can see that almost all the available softwares are installed on this controller. But what we can do is we can click here and downgrade the controller to previous versions or upgrade it whenever there is an update available, or we can select another library and just simply install it to the controller. We have all the libraries that are available on the controller that we'll be using for programming the controller itself. And last but not least is the tree. So the tree is the heart of the device. It is where we keep all of our containers, like the system, services, networks, and applications. So what can you do with the system? You can easily go here to the platform and change the IP address, set the DHCP. You can set the time here. As I mentioned, you can just set the time from the station, or if you would like to choose that, you can set the custom time. You can go to the backups and you can create a backup locally on the device, or you can go and make a backup to your Niagara station, which is then saved into your files right in the station. We can go to the files and under changing backups, and you can see my golden backup version to final free version 2 is saved here safely. So going further, we have all the networks. So the local IOs, we can add the local IO here. For example, analog output, we can name it AO1, save it. And what we can do here next is just attach it to and bind it to the proper number of the output. So that's the output number 1. It's enabled. That's all we have to do. It's by default set to millivolts. And now we can go to, let's say, the application container. I mentioned you can run multiple applications in different time cycles. So here we can go to the application number 1. Scan period is just 200 milliseconds. I can go to my FCU here, which is equipment we'll use to run the application on the device. I mentioned the new feature, which is saving to the palette. It means that we can save from the palette as well. So as you can see, we have the palette file. It's a standard Niagara palette file I can open here from my browsing category. And what it allows you to do is just save your application for later, copy it, and then just paste it to your controller right here. So once this is done, the only thing we need to do is just go and link this heater component that is connected to the ramp controller component over a link. We can create a link mark, link it to the analog output 1 we just set using the link from, create the reference between those components, and you should see here that this application is running. So that's the connection over the USB, but we can do exactly the same thing using this RAC18 IP that is on the backnet network. So only thing we need to do is go to connect, put the IP address. I have the default IP address here, and we can connect to this device right here in the extension. You see those bulbs changing colors. It means that the connection is ongoing. When it's yellow, it's loading, and when it's green, the connection is established. So what we can see here again is the tree of the second device to which we are connected over IP. And again, we can go to the first device. We can copy the whole logic from the first device. We can open the second one, and yeah, we can just simply create a new equipment here. Go to the equipment and paste this logic. It's going to execute itself again. And we can add another local IOs or just copy it from the previous device. Go to the local IOs, paste it here. So we have the other analog output set here in the device. Do the same link that we did in this first extension. So go to the application. We can do that either on the wiresheet or in the tree. Link this heater with our local IO. Use the same reference. And using this simple copy and paste, we can build the application, copy the applications between controllers, or just simply deploy it. Please keep in mind that all data points that we are adding to the application, they are shared over BACnet and Modbus protocols. So for the integration purposes, you will be using the Niagara BACnet network to discover all the points directly in your Niagara network. Right here. So I think that's it for the demo today. We've been 1 minute after the time. I hope you don't mind that. Would like to greatly thank you for joining our webinar. If you have any questions to ask, please share them over the chat. We are very thankful for you to join in this session, and we hope to do another session in the future for you. So see you soon.
So thank you.
Thank you very much.
Thank you.